New observations push Atlas back into the scientific spotlight. New observations and measurements have brought 3I Atlas back to the forefront of scientific attention. This time, not due to rumors or speculation, but because of a concrete sequence of results that demand a serious reevaluation of everything we thought we knew about this interstellar visitor. The most recent post-perihelion images reveal a compact nucleus with no massive tail, while precision astrometric data shows lateral displacement and non-gravitational acceleration, a phenomenon that continues to challenge our understanding of cometary physics. But something even more disturbing is happening behind the scenes. Political shakeups and withheld data, sudden administrative changes at space agencies, strategic dismissals, and growing speculation about politically motivated image suppression are stirring concern. On November 4, 2025, President Donald Trump made an announcement that shocked the scientific community. On his Truth Social platform, Trump declared the replacement of NASA Administrator Sean Duffy with billionaire Jared Isaacman. The timing raised eyebrows. Many noted that this replacement came immediately after a controversial tweet exchange involving Kim Kardashian, causing widespread speculation throughout the astronomical community. Was this a routine change, or was it linked to what NASA knows about Atlas? As the American government shutdown stalled the release of high-resolution images, particularly those from the HiRISE camera, something extraordinary happened. China breaks the silence. China's National Space Administration released never-before-seen images captured on October 3, 2025, by the Tianwen-1 Mars orbiter, at a distance of 28.96 million kilometers from Atlas. These were not amateur captures. They were professional-grade scientific images from one of the world's most advanced space missions. Tianwen-1, which entered Mars orbit in February 2021, used its HiRIC camera, equipped with a 38.7 cm primary mirror. Although it has a slightly lower resolution than NASA's 50 cm or HiRISE, the Chinese images were revolutionary. They revealed Atlas's nucleus, a coma several thousand kilometers wide, and an animated sequence of 30-second exposures tracking the object's real-time movement in the Martian sky. An explosive congressional statement. In an unexpected turn, a U.S. Congresswoman broke the silence. On her social media, she posted, "Just had a good conversation with NASA about Atlas. As soon as the government reopens, they'll release the images and data. Unfortunately, for bureaucratic reasons, it can't happen until then." Dr. Avi Loeb was correct in his early analysis about the anomalous tail. NASA saw it too. I'm confident we'll track many more interstellar objects as our technology improves. This statement is explosive for 3 reasons. 1. It confirms NASA observed the same anomalies Avi Loeb identified. 2. It suggests there are more interstellar objects with unexplained behavior. 3. It admits that critical data is being withheld for bureaucratic reasons. Trajectory and acceleration anomalies. Latest models based on post-perihelion observations highlight 2 critical anomalies. 1. Inexplicable lateral displacement. The object deviated sideways, left-right, from its predicted path, with no vertical displacement, suggesting a controlled movement. 2. Persistent non-gravitational acceleration. Although revised to about 1/3 of the original post-perihelion value, the signal remains statistically significant and unexplained by known gravitational forces. In orbital mechanics, this implies that in-plane acceleration components, A1 and A2, are present, while the out-of-plane component, A3, remains near zero, indicating radial and lateral forces acting without lifting the object from its trajectory plane. The 5 billion ton paradox. According to classical cometary physics, non-gravitational acceleration is caused by mass ejection, producing a rocket-like thrust. Based on Atlas's observed acceleration and using typical gas ejection velocities, hundreds of meters per second, it should have lost over 13% of its mass, a release of billions of tons of dust and gas, forming a vast invisible coma and tail. But that didn't happen. Instead, the coma remains modest, the nucleus compact, and there is no observable debris cloud matching expected mass loss. Even with a lower acceleration estimate, the paradox remains. There's acceleration, but not the ejecta to explain it. Anomalous composition and optical signals. Preliminary spectroscopy and comparative analyses show nickel dominance with almost no iron, extremely high CO to water ratio, possible industrial byproducts like nickel tetracarbonyl, extreme negative optical polarization, consistent with large, porous, complex particles, unlike any seen in known comets. These findings are incompatible with traditional cometary origins from cold, primitive regions of space. 3 remaining hypotheses. Only 3 scientifically viable hypotheses remain. 1. Atypical natural comet, possibly ejecting material at high velocities, forming no significant coma. 2. Non-thermal propulsion, internal engines or unknown mechanisms causing controlled movement with minimal mass loss. 3. Artificial probe, requires extraordinary evidence, geometric structure, industrial compounds, or emissions proving artificiality. While improbable, this cannot be dismissed without further data. The 10 definitive Atlas anomalies. 1. Retrograde orbit, aligned with the ecliptic. Statistically unlikely for an interstellar object. 2. Antitail, directed toward the Sun, opposes classical expectations. 3. Large mass, with high speed, suggests unusual material strength. 4. Coordinated planetary flybys. Limited observation opportunities suggest deliberate trajectory. 5. Unusual composition, high nickel, no iron, abnormal CO-H2O ratios. 6. Extreme negative polarization, not observed in typical solar system comets. 7. Origin aligns with 1977 WOW signal. Directional coincidence stirs renewed CT interest. 8. Anomalous photometric evolution. Brightness peaks and green emissions defy comet norms. 9. No debris cloud despite acceleration. Mass loss model fails. 10. Symmetric ejection without recoil contradicts Newtonian expectations. The critical window, December 2025. A coordinated international observation campaign is scheduled between late November and January, with a decisive moment on December 19, 2025. Key objectives: detect extensive coma indicating 10% mass loss. Identify spectroscopic markers, CO, H2O, nickel, exotic compounds. Look for non-thermal emissions, gamma rays, microwaves. Perform polarization mapping to analyze particle structures. Collect high-precision astrometric data to confirm or rule out controlled maneuvers. The results from this window may distinguish between a natural anomaly, exotic propulsion, or an artificial origin, a revelation that could reshape everything we know about interstellar objects.